Alright, we're going to do a lot more U sub, or U sub for short, but U substitution today, just for practice, getting used to the process, letting us get a little bit familiar with how to identify the inside, what U should be, and then we'll go ahead and work with our antiderivatives. Let's just go ahead and reference the 5 integrals that we should be familiar with. Remember, our goal is to turn all of these complicated integrals into one of these simpler ones. That way we can work backwards from it and find that antiderivative. Mark is fine. Can we work backwards from x to a power? What would the antiderivative look like? I know yesterday I had numbers for this one, but let's try to look in a general sense today. How can we work backwards from x to a power? The reverse power rule.
X to the n plus 1.
Okay, we add 1 to the power.
Over n plus 1.
Over 1 plus 1. So the coefficient would be 1 over n plus 1. That's in a general sense. You could throw in numbers, you could put a number out front and add a number. It would work the same way. All right? What if we work backwards from cosine? The same? Good. Okay. All right. We work backwards from sine. Negative cosine. Good. We work backwards from 1 over x. Yeah, natural log. And we work backwards from e to the x. Yeah? E to the x. Good. We've got to know those 5. All right. So I forget where we left off yesterday. I'm pretty sure we have the bottom 2 to do, but did we have any of the other ones? No? Just the bottom 2? Okay. Let's check out the first one. Notice how it's a complicated integral. It's not just e to the x power. We have other numbers going on in there. So what can we identify as kind of the inside part? What do we want to let u be? Three x, okay? The inside part for an exponential is usually the power spot. So if we take the derivative of that, we'll get 3. With those 2 equations, we're going to rewrite the original integral. We're going to keep the 5 and we're going to keep the e. The only thing we're going to change is that power of 3x because we said it should be u. We also want to rewrite the dx because we're trying to change all of the x's into u's, a more easier integral to work backwards from. What should we replace the dx with? Yeah? du over 3. Perfect. All right, so notice how all the x's are gone. That's wonderful. Let's go ahead and try to work backwards from this. Now, it might be in our best interest to rearrange certain things. Notice how we have a multiplication of 5 and a division of 3. So we can merge those together as 5 over 3, make that the coefficient out front. And all we have to do is work backwards from e to the u, which is one of the 5 that we have. So we'll keep the 5/3, that coefficient. If we work backwards from e to the u, we get e to the u. We don't know the bounds, so we need the plus c. And last but not least, we said u was 3x. If you wanted to check your work, okay, you could take the derivative of this and hopefully you get 5e to the 3x back. You can always check your work with these. That's what's really nice. Do we kind of remember that process from yesterday? Or at least referencing it, it came back to us a little bit? All right, let's try the next one. very complicated integral with x's. Let's change it into an easier integral with u's. What do you want to let the inside be? 2x squared plus 3, okay. If we take the derivative of that, we'll get 4x. Let's rewrite the integral and hopefully all the x's will go away. So we're going to keep the 3x. Down below, we're going to have the square root of u, but maybe you want to rewrite that as u to the 1/2 power. And we're going to rewrite the dx on the end. All the x's got changed to u's. So dx would be du over 4x. Will the x's go away? Thank goodness we have one up top, one down below. They go away. So all we're left with are u's, which was great. Let's rearrange it a little bit so it's easier for us to work backwards from. We have a 3 divided by 4, so we'll write that as a coefficient. And maybe we want to bring that u to the 1/2 up to the top of the fraction, and we'll give it a negative power. Alright, so we got to work backwards from 3/4 u to the negative 1/2. It looks like we're going to have to use our reverse power rule, one of the top one on the board. So let's try it. If we add 1 to the power, we'll get 1/2. And then we got to take the coefficient divided by that new power. So we got a lot of fraction work here. We need 3/4 divided by 1/2. What are we going to be left with? Yeah? 3/2, 3 over 2. Good. And then the plus c. Last but not least, we know what u is. After all, we picked it. So we'll have 3/2 and then 2x squared plus 3 all to the 1/2 power plus c on the end. If you want to rewrite the 1/2 as a square root, you can definitely do that. I mean, they mean the same thing. I'm hoping we're starting to get into a groove with these because it's kind of the same process over and over and over again. It just depends on what you let u be and whether you have to rearrange some things. Okay, I'm hoping it's starting to sink in a little bit. We're going to check out some special ones today, and I don't want to give too much away, but we'll see kind of what happens with these. So I don't really want to read what's going on in this page. I just want to talk about it more with you guys. Let's say we were given this example here. What would you want to let u be, that inside piece? Can we just talk about it? What do you, 2x minus 1? Okay, that to me looks like something on the inside. Okay, let's go ahead and take the derivative of that. We would just get 2. All right, if this were like any other problem, let's go ahead and we're going to rewrite the integral. So we have that x out front, and we're going to replace the 2x minus 1 with a u. And that needs to be to the 3rd power. Let's go ahead and replace the dx on the end. That would be du over 2. Right? That's everything we've been doing in all the other examples. The same process all the way through. What do you notice about this one? The x doesn't cancel, right? Isn't that what happened in all the other ones? And we wanted that to happen, that way we were just left with u's. So we're going to have to be a little strategic here, okay? In this case, the x doesn't cancel. That doesn't mean we're done, okay, that we can't continue with this u substitution process. That just means we have to somehow think about how can we replace this x with something involving a u. We're going to have to do another substitution. So not only did we have to substitute u in for the 2x minus 1, but we got to substitute something in here. Do you think we can figure out or use something we already have to help us replace the x? Yeah.
Use the original u function and solve for x.
Solve for x. Okay, let's do that in this bottom box. Okay, so we have u equals 2x minus 1. Let's solve for x. We'll go ahead and add the 1. And then we'll divide everything by 2. So I might represent that as 1/2 u plus 1/2. I divided everything by 2. Now that we know what x is in terms of a u, let's replace that up here with this x. So we'll have 1/2 u plus 1/2, and then the u to the third, and then the du over 2. Now are all the x's gone? That's better. Okay? So it's really nice when all the x's go away on their own, like they did in all the other examples we did yesterday and at the beginning of today. But it's not the end of the world if the x's don't go away. We just might have to do a little extra solving here to help us replace an x that's left. Let's go ahead and try to clean this up a bit. Okay? It looks like we can probably distribute in that u to the third, but then we can also distribute in that 2 that's in the denominator. Okay, so we'll bring in the x to the third, or u to the third, and then that 2. So if we bring in the u to the third, our first term would be a u to the fourth. And then if we bring in that 2 in the denominator, our new coefficient would be 1/4. All right, let's do the next distribution. So if we bring in a u to the third, that's going to stay a u to the third. And then if we distribute in that bottom value of 2, our coefficient will be 1/4. And then we just have the du on the end. Can we work backwards from those 2 terms now? Can't we use the reverse power rule? Let's try it. So we'll add 1 to the power, which would be 5, and then we need 1/4 divided by 5. Be careful with your fractions. What would we be left with? One over 20, good. Okay, and then let's do the reverse power rule on the next term. We'll add 1 to the power. Divide the coefficient by that new power, we'd have 1 over 16. Let's not forget the plus c. All right, last but not least, we're going to substitute what we let u be, and that was the 2x minus 1. So we need a 2x minus 1 to the 5th power, and then in the second term, we need a 2x minus 1 to the 4th power. All right, so it's not the end of the world if the x's don't go away. It would be extremely nice if they did, just because we saw how easily that worked out for us in the first few examples. But if it doesn't go away, that's okay. We just got to rework it somehow. We got to do another substitution. All right, let's try another one on the back. What do you want to let u be? What kind of looks like on the inside of something? X plus 4, okay. Let's go ahead and find the derivative. That would just be 1. Let's go ahead and rewrite the integral. We're going to assume this is any other example we've been doing. I know we have the nice chart and boxes in there to kind of guide us, but let's just assume this was any other problem. We're going to work it out any other way. This would be a 2x plus 1 up top, and we would need a u to the 1/2 down below. Replacing the dx, that would be du over 1. but that's just du. Did the x cancel? No, unfortunately not, okay? So let's go ahead and do another substitution. We'll take that u equation and solve for x. Looks like we get u minus 4. All right. So somehow, now that all the x's are gone, this u integral should be much easier for us to work backwards from. At this point, though, with the way it looks, I don't think it looks too easy. Okay, but maybe we can clean it up and simplify it a little bit, because eventually we wanted to make it look like one of those 5 integrals that we should be familiar with. Okay, so what are some algebraic things you might want to do to clean it up a bit? Yeah. Let's distribute the 2. All right, so 2u minus 8 plus 1. Can we keep going? Yeah. Yep, so that would be minus 7. Can we keep going? Yeah. Okay. So if we move the u up, that would become a u to the negative 1/2. And then we're going to have the whole top left in parentheses. If you bring something up, you got to multiply it by all of the numerator. Can we keep going? There we go. Let's distribute. Okay, so if you're distributing in the u, you'll have to add the powers. Negative 1/2 plus 1 would be a 1/2, and then we'll have a minus 7u to the negative 1/2 du. I think that looks good because we can now use our reverse power rule. All right, so let's add 1 to the power, and we'll divide the coefficient by the new power. So 2 divided by 3/2, we'd have 4/3. And then if we add 1 to the next power, that would be 1/2. Negative 7 divided by 1/2 is a negative 14. And let's not forget the plus c. So now that we have our antiderivative, we'll just go ahead and plug in our u, which was the x plus 4. Alright, so again, it's not the end of the world if the x's don't go away. We might just have to do another substitution, but it's going to be in your best interest to clean it up and eventually get it to look like one of those 5 that we can easily work backwards from. Alright, let's go ahead and try this last one here. This one's a little bit different than the ones we've been doing because notice how we have the bounds. So we're not going to need the plus c anymore. This means we're actually should be getting a numbered value, a numeric value in the end, because we can use that fundamental theorem of top minus bottom. Okay, so let's go ahead. This looks like a very complicated integral with x's. Let's maybe turn it into an easier integral with u's. What do you want to let u be? Two x plus 1, okay? So then du over dx would be 2. Alright, let's rewrite the integral. So we'll have x square root of u, or you can write that as u to the 1/2, and then instead of the dx, looks like we'll have du over 2. Did the x go away? Unfortunately not, right? Okay, but it's not the end of the world. Okay, we're going to go ahead and take the u equation and solve it for x. So we got to subtract 1 and then divide the 2. Looks like we get 1/2 u minus 1/2. So we'll go ahead and replace that for the x that was still left in there. Alright, so now that all the x's are gone, supposedly this new integral should be easier for us to work backwards from, but the way it looks right now, to me, that doesn't look very simple. So let's go ahead and clean it up. What might you want to do? Distribute. Okay, so we're going to distribute in the u to the 1/2, but we'll also distribute in that denominator of 2 that we had left over. So this would be a 1/4 u to the 3/2 minus a 1/4 u to the 1/2. And then the du's left on the end. Alright, looks pretty simple from here. We can probably use our reverse power rule, so let's go ahead and find our antiderivative. We'll add 1 to the power to get 5/2, and then we need 1/4 divided by 5/2. Looks like that'd be 1/10. Hi. Thank you. Let's try the next one. If we add 1 to the power, we'll have u to the 3/2. And then we got to take negative 1/4 divided by 3/2. I think we get negative 1/6. Are we doing okay with those fractions? Do we got to check them out? Are we okay? Do we need the plus c? No. Okay, so let's go ahead and we'll substitute in the u. We had 2x plus 1 minus 1/6, 2x plus 1, and then we'll throw in the bracket, and our bounds were 0 to 4. Alright, this is when I want you to use your calculator, because it's going to be a little complicated from here. Which bound do we plug in first? The top. Alright, so on your calculator, I want you to plug in 4 for all of those x's. I feel ya. My husband came home from work yesterday and he looked like death. And then everyone at daycare has been throwing up recently, so it's like bound to hit my kids at some point. And I woke up with a scratchy throat. Yeah. Let's see, after you plug in 4 for all the x's, I got 19.8. Does that sound about right? Okay. Now we have to subtract what we get when we plug in 0. Negative 0.0667. All right, so top minus bottom, we get 19.867. Sound right? All right, so that's what we get by hand up to a point, like we used our calculator to help us evaluate it. But let's go ahead and see if we were to type in that exact starting integral on our calculator, hopefully we would get the same answer. Maybe we'll double check it just to make sure that we did the u substitution correctly. So we'll do math 9, 0 to 4. We need x square root of 2x plus 1. $19.867. So it looks like we did the u substitution correctly, right? So far, so good. Are we doing okay? All right. There's one more thing that I want to talk about with this question, okay? Since, and this is really important, okay? Since we're changing this original x integral into u's, do you think I can still put a bound of 0 to 4 on this u integral? We're going from 0 to 4 in terms of x's. Do you think it's still 0 to 4 in terms of u's? What if we were to try it, okay? On your calculator, let's do math 9. We'll bring up that integral. If we were to type in the bounds from 0 to 4, let's go ahead and type in our u integral that we had in the end. I know instead of, you can't type in u's on your calculator, so we'll just use x's. But we'll need 1 divided by 4, x to the 3/2 power, and then we'll do minus 1 divided by 4, x to the 1/2 power, dx on the end. We should get 19.867 because this u integral is exactly the same as the x integral, it just looks differently, or looks different. Do they match? No. Okay, so here's the thing. Even though the original bounds were 0 to 4 for the x integral, those are not the equivalent bounds for the u integral. How do you think we can figure out what the new bounds might be for the u integral? What do you think? Let's use that u equation. Okay, let's try it. So if we let this bottom bound of 0 plug it in for x, we would get 1. And if we take the upper bound of 4, which is representing an x value on the x-axis, if we plug that in for x, we'll get 9. Let's see if that works. Okay, so I'll just hit second entry to bring up the integral we just typed in. And instead of 0 to 4, let's change it from 1 to 9. Does it match? Yeah. Okay, so we got to be careful. Okay, the only way you can use the 0 and 4 is if you plug in the u that you labeled back into the equation. Okay, so if we were to actually write this out, it would look like the integral from 0 to 4 of x square root of 2x plus 1 is equal to the integral from 1 to 9 of that u integral that we found using the u substitution. Okay, those are equivalent. They are exactly the same. So when you change the integral from x's to u's, you actually change the bounds as well. Does that make sense? If you're changing the variables, you're changing the bounds that they represent. Now if you wanted to, okay, what we could have done At this point right here, after we found that antiderivative, we could have thrown in that bracket and done 1 to 9. Isn't that the same thing as throwing in the bracket from 0 to 4 after we plug the x's back in? Okay, if you wanted to do plug in 9 minus plug in 1, you should get the same value. So what's neat is if you're actually solving for a number, meaning you have the bounds, you can either utilize the u antiderivative you found, making sure that you change those bounds appropriately, or you can replace the u with what you let it be in the first place and use the original bounds from the integral. They are the exact same thing. So we got to be careful that we make that distinction between the two integrals. Even though the original bounds were 0 to 4, those are equivalent for 1 to 9 on that new integral we found. I hope that makes sense, because notice how we get the same answer in the end. Okay? Let's see, do we want to try some practice problems from the homework for u substitution? Yes? Okay. Let's take a look on page 417. Anyone in particular we want to check out if you had a chance to start some? Or is there one on the page that kind of like immediately jumps out at you that might be a little tricky or cumbersome? Which one?
Do 4.
4? Okay. What do we want to let u be? Does something look like to be on the inside of something? There we go, 1 plus x to the 4th. All right, so then the derivative of that will have 4x cubed. Let's go ahead and rewrite the original integral. The x to the 3rd up top it stays. On the bottom we'll have u squared, and instead of dx we'll have du over 4x cubed. Do the x's cancel? Thank goodness, right? We don't have to rewrite that u equation. All right, so somehow this u integral we have left should match one of the 5 that we are familiar with. Maybe we'll rewrite it. We're going to have a 1/4 coefficient, and instead of the u squared down below, maybe we'll bring it up and write it as a negative power. Let's work backwards. We'll find our antiderivative. We'll add 1 to the power, divide the coefficient by the new power. We don't know the bounds, so we need that plus c. So it looks like we'll have negative 1 over 4, and then 1 plus x to the 4th to the negative 1st, plus c. You can leave it like that. If you don't like the negative power, you can move it to the bottom of the fraction. It would go where that 4 is in the coefficient out front. Let's see. For number 6, just so we don't get confused, you can change those u's to x's if you prefer, like all the other ones. It might get a little tricky using u substitution on an integral that already has u's in it. So if you want to change those to x's, you can. Let's see, any other ones you guys want to check out? Front or back? 8 on the back? All right. What do we want to let u be? This was a little tricky. What kind of looks to be on the inside of something? Both of them, right? Is there one of them that seems to be a little bit more complicated that would be worth our while to rewrite? This is probably the square root one. Let's try 2 minus x. So then the derivative would be negative 1. Let's go ahead and rewrite it. So the x plus 1 out front stays. The square root, though, will change to u to the 1/2. And instead of dx, looks like we'll have du over -1. Did the x's cancel? Nope, it's not the end of the world, though. What are we going to do? Solve for x. All right, so let's take that u equation, and we'll get the x all by itself. Looks like we'll get 2 minus u. All right, so in for that x, we'll plug in 2 minus u. Then we have the plus 1, u to the 1/2 after that, and then du over -1 on the end. So now that all the x's are gone, we should be able to easily work backwards from it. It should look like one of the 5 integrals we are familiar with, but we may have to clean it up. Where do you want to go from there? Okay, we can distribute. And maybe we can simplify. How about we do 2 plus 1 first? I think we can do that. So this would be 3 minus u. And let's go ahead and distribute from here. So we got to distribute in the u to the 1/2, but also the -1 that's in the denominator. So this would be -3 u to the 1/2. And then plus u to the 3/2 power. And we're just left with the du on the end. Bless you. That was. Do you guys think you can go from there? Reverse power rule. Don't forget the plus c. And I'm hoping we're starting to get into a groove with these. How'd you do? Can you check it? Looking good? Awesome. All right. Bell's going to ring in a little bit. Try some more of these U substitution problems tonight if you can. And if you have any questions, we can definitely go over them tomorrow. All right?